Hi there, and welcome to this edition of Developer Superpowers. I'm David Burela, and today we're talking about Xamarin.Forms and MVVM from first principles. So you may have seen our previous video on Xamarin. So if you haven't seen that, Adam Stevenson previously did a video introducing Xamarin.Forms. So that's a good place to start to cover all of the basics of how to get Xamarin installed and set up on your machine. I'm going to assume that you've got some basic knowledge of Xamarin. If not, then you can still watch, and you'll get a rough idea of how to get started with Xamarin.Forms. Today, we're going to go through a few different things. We're going to start off with covering what Xamarin.Forms is. We're going to talk about how it is a way of defining your user interface once and how it renders on multiple different devices. From then, we're going to look at how we can use Xamarin.Forms with XAML. After that, we'll move on talking about MVVM, Model, View, ViewModel. We're going to talk about what it is, and then we're going to implement it by hand by ourselves, not using any other frameworks. We're going to build it up from scratch, and we're going to explain every step what's happening. So I don't just want to show you how to do things today, I want you to understand how things are working. And while we're explaining MVVM, right at the end, we're going to have to cover some more concepts inside of MVVM, such as commanding, as well as the iNotify property change interface. So let's just jump straight into it. So I've only got 4 or 5 slides today, and the rest of the session is going to be pure code demos. So we'll move on from the slides very soon. So Xamarin.Forms. Now Xamarin, if you saw that previous video, allows you to write applications that will run in .NET that will run on iPhone and Android. Now, one of the concerns that people have is that that's all well and good. They can write .NET code and they can share some of the business logic in the back end, but when it comes to the user interface, they needed to define the user interface multiple times. They had to define it for the iPhone application, then they had to redefine it for the Android, and again for the Windows Phone. Now, as you can see on the slide that I've got here, Xamarin.Forms allows you to just define the user interface once, and it's going to look correct on each of the platforms. It's going to use the native controls on each of those platforms to make the application look correct. It's not going to look like an application that's just been written and is being forced and shoehorned into each of these different platforms. So we can see here in this picture that we've got a tab control. So here on the favorites, but here we go. We'll see we can flick between map and customers up the top because that's Android. Windows Phone, we've got a pivot control instead of tabs, so we can flip between map and customers. And on iPhone, their user interface is defined in a different way. So they've got the tabs down the bottom, so we can see map and customers there. And then we can see each of the platforms have their native map control there. We've got the Google Maps, we've got the Apple Maps, and we've got Bing Maps right there on the right-hand side. So that's the basics of Xamarin.Forms, and what the great thing about it is. We define it once and it will look like a native application on each of those platforms. And you're going to have a great user interface speed because it's going to be rendering as fast as a native UI because it is a native UI. Now, Xamarin.Forms have come out with a lot of different controls for you to use. So what they have in the box is a whole bunch of different pages, so different base views for you to use. So you've got a content page, which just covers, we just display things on a page. We've got master detail page, navigation page. So if you want to navigate through and go click on a customer, click on one of their orders. So you're navigating through, so that'll happen up the top for you. The tabbed page that we saw on the previous screen, and then a carousel page if you want to flick through them. So that's for the different types of views. Now we've got different type of layouts as well. So I'm going to be using this one very heavily, the stack layout. On Windows Phone, that's called the stack panel. So stack layout, most of my user interfaces are done with this because it's a great way to get started. In the stack layout, each of the controls will be layered one under the other. Absolute layout, if you want to define exactly where things are, relative layout, grid layout, etc. So I'm not going to cover all of these today. Now, as well as defining the different pages in your application, you're going to need to display something on those pages. So here we have controls. So they've got all the basic controls that you're going to need. They've got labels, text boxes, images, the map, an activity indicator to show if you're busy. And so I'll be showing a few of these ones today, but there are more that can be used. So this is all of the controls that are in the box with Xamarin.Forms, but there are control vendors which you can use to get more controls, such as Telerik, Infogistics, DevExpress. Now, just to drive this concept home just one last time, so here's one user interface where they've used three different things. We've got a tabbed layout, so again we can see up the top, tabs, and at the bottom for the iPhone, and they've defined three different controls in here. We've got a text box, a password field, and a button, and we can see that they're being rendered using the native controls. So Windows Phone is all square, Android just has an underline, and an iPhone it looks more like a traditional text box, but the buttons all look different as well. So with that, that's all the slides that I'm going to show today. So we're going to dive straight into code. So I'm going to create a brand new project in Visual Studio. So steps that I've done so far. I've installed Visual Studio 2013, and then I've gone and installed the latest version of Xamarin. I've also got ReSharper on here because you need ReSharper if you're a developer. So those are the three things that I have on this machine. On my other machine that I have here, I've got a Mac laptop here. And on here, it's I actually wiped it before I came into this presentation. So I wiped it, updated to the latest version of Mac OS X. I then installed on Xcode and then the latest version of the Xamarin tools. So Xamarin is now running on this machine, and this is going to be doing two things for me. I'm going to be building all of my Xamarin code here on my Windows machine. For the majority of this presentation, I'll be doing it in Windows Phone and Android because it's just quicker and easier to do it all on the same machine. And when I get to some certain checkpoints, I'll go and connect it to the Mac, get Visual Studio to send the build request to the Mac. It will build it, and then it will load up the iPhone simulator and deploy my application to here. And so I'll do this only a few times so we can see that what user interfaces look like on each of those three platforms. So now that we have Visual Studio open, we're going to go File, New Project. We're going to go to Mobile Applications, and we're going to click the Xamarin.Forms Portable application. Now, there are two different ones here. There's the shared, and then there's the portable. With the shared project, I have nothing but problems with it because it doesn't. The shared project doesn't have its own namespace. It kind of inherits a namespace of each of the three child applications. I was always having problems with just namespacing issues and XAML not being able to find .NET classes that I needed. So it was just difficult. So my number one tip is always create a Xamarin.Forms portable project. If you start with that, you can't go wrong. So today we're going to call this application our Dev Superpowers demo. We'll hit OK. So that's going to go off and create a new solution for us with 4 different projects. Now, at the end of this presentation, once I've finished all of this, I'll go and upload all of my code today up onto GitHub. So in the description at the bottom of the video, or if you're on the live stream, I'll add a link to it. So then you can go onto GitHub and you can download my source code. And then once Visual Studio has finished creating 4 different those projects for us, we can have a look at what we've got. So I'll collapse all of these. So we have 4 different projects. We've got one for each platform that we're going to be targeting. We have one for Windows Phone. Here it's defined a Windows Phone 8 project. So they'll hopefully update this to Windows 8.1 soon, or Windows 10 because that will be coming out very soon. We have one project for iOS and one for Android. Now we do need those 3 projects because those are going to be building the 3 final assemblies for us, one for each platform. And if we go into them, each of these applications are going to have something that they need to define. So inside of our iOS application, we need to define the application artwork, the security requirements that it needs, etc. Same thing with the Windows Phone. We need to define what the application icon is. We need to define which security permissions it needs. So we do need these three, but we're not going to be building anything inside of these. Now, the fourth one that we have here is our portable class library. All of our business logic, all of our XAML views, all of our everything are going to be there inside of this portable class library. This portable class library is going to be compiled and then added to each of those three projects, and then those three projects will get all of the business logic from this one shared portable class library. If we right click and go into the properties, we can click change and we can see all of the different platforms that our PCL is targeting. We're targeting Xamarin iOS, Xamarin Android, Windows Phone, and Windows 8. Great. So without doing anything else, let's start with the Windows Phone project. There we go, and hit run. So with a fresh new project, let's just have a look at what they give us. So it's going to compile it, it's going to deploy it to our Windows Phone emulator, and here we go. All it says is welcome to Xamarin.Forms. Not very sexy. So let's just have a quick look at how it's doing that before we replace it all. So inside the portable class library, we just have an apps.cs, and inside there, app.cs, it's defining our main page. So when application starts, what is our main page? And they're creating a new Xamarin.Forms page here in code. So we've got a stack layout. It's setting some options on the stack layout, and then it's adding a label as a child. So that's all it's doing in code. So in code, it is creating our Xamarin.Forms view, and then it's just setting that to be our main view. That's all that's happening. And in each side of these three different projects, we have, all they're doing is nothing more than bootstrapping. So if we go into the Windows Phone project, go into the app.xaml, we'll probably see something that says main, not there, oh, main page.xaml. One of these ones, here we go. It creates a new Dev Superpowers.app, which is this class, and then it goes from there. And all three of those applications are going to be structured very similarly. All they are just shells that do nothing but start what's inside the portable class library. So let's close all of these. Now you can define your user interface in C# code, but to me it gets very complicated very quickly. I'm more of a XAML developer, so instead we're going to delete all the C# code and we're going to define our view in XAML. So let's get this project structured nicely. So we're going to right click, add a new folder, called views. We're going to create all of our XAML views inside of here. We right click, add a new item. And we want to create a new forms XAML page. Now these other two, the content page and content view, actually just create .cs files so that you can create your user interface in C#. We don't want that. We want a forms XAML view, and we're going to call this demo view. We'll hit add. Great, nice and easy. So let's just replicate exactly what was in that C# code. So in C# they defined a stack layout with, so if we look back here, so we've got a stack layout. Vertical options were sent to center, so let's just do that. Vertical options equals center. So this is ReSharper helping us out with the IntelliSense. Now inside of that we had one child which had a label with its text saying welcome to Xamarin.Forms. Let's copy that. Text, change that to say welcome to Xamarin.Forms from XAML. We'll save that. And we'll hit, oh, that will not work. So we have defined our view in XAML inside of our views folder, but now we have to change the portable class library to, instead of instantiating the view from code, to instantiate our view that we created in XAML. So we're going to go back to the app.cs. We're going to delete all of this, and we're going to say, instead of doing all of that, we're going to say main page equals a new demo view. Save. Now if we hit run, Now, I'm using the Windows Phone emulator for the majority of this because it's the fastest emulator. We can see there it took 2 seconds to try and load it up. To do anything with any of the other emulators would take us a little while. So that's why the vast majority of this, I'm going to do this using the Windows Phone emulator. So we can see here, it's loaded up and it says, welcome Xamarin.Forms from XAML. Okay, that's kind of cool. Now, we could go and load it up in the other platforms, but let's add a few more things to it to make it sexy first. Okay. Stack layout, we've got our view. So now that we've started off with our XAML, this is all well and good, but let's add a few more things. We have a label which says welcome to Xamarin.Forms. So what we're going to do is change this. So instead of just having a label, we're going to have 3 controls. A label, a text entry so that we can enter what our name is, and then a button. So we can click the button and it will update the label to say hello, whatever our name is. So let's add in those other controls. We need a text entry field. The text can say, enter your name. Button, text can be, say, hello. Now, because we are going to be modifying and getting properties of these controls, we're going to need to give them names. So our label, let's give it a name of greeting label, because we're going to put our greeting in there. The entry field, we're entering in the name. X name is going to be the name entry. Great, so now we can go and pull the name out of this field and then update our greeting with text from here. So the last thing we need to do is our button. Our button, we need to have a clicked event. When we click this button, we're going to do something. So we tell it to create this method for us. Let's change this to say, hello button is clicked. When we click the button, we're going to get the person's name, which is going to be in the name entry field, dot text. So we can grab the text property from this field. We're going to create a greeting, which is going to be hello plus the person's name. Then finally, we're going to get the greeting label and set that text to be the greeting. Now, I could have done all of this in one line, but I'm just putting it out into 3 to show step by step what we're doing. We're referencing one control, creating the new greeting, and then we're going and updating a second control, which is being invoked from being clicked on a third control. And we're being very explicit, and we know every control that's being interacted with here. So if we press run, everything will spin up, and there we go. It says, welcome to Xamarin.Forms from XAML. Please enter your name. Put in my name, David Burela. We click say hello, and it updates it. That's okay. Now let's go and spin this application up on each of these different platforms. So first we're going to set our iOS application as, no, first let's do Android, so I'm still on the same machine. Set a startup project, and we press run. Now, when you install, that's going to take a few moments to spin up. After you install that and the Xamarin package onto your computer, it goes and installs on the Android SDK, the Android NDK, and a few base emulators. What you will have to do a few things more to get your Android emulator ready. Now, when you have Visual Studio 2015, things will be much better. Visual Studio 2015 bundles a hypervisor-based Android emulator in with Visual Studio 2015. So the Android emulator is much, much, much faster. Because I'm currently using Visual Studio 2013 on this machine, I'm demoing with the base Android emulator. So to get this running, I had to click here, Android, open the Android SDK manager. I went into Android 19 and I installed the ARM and Intel, it's all moved on me, 19, I installed the ARM and Intel Android emulator images. Now, because I'm using the hypervisor on this machine to use the Windows Phone emulator, we can't use the Intel Xamarin virtualizing technology. So as I said, when Visual Studio 2015 comes out, it's all fine because we use that emulator. Because we're using the Android emulator here, we can't use both simultaneously. So what I need to do, if I close this, we open up the Android emulator options, and we create a new one. So if we click edit on this, I'm using the ARM CPU because that way we don't have virtualization issues. We set that we want it to be a very high API level and then use a GPU. That's it. And so I'm emulating a Galaxy Nexus here. There you go, and it's finished doing that. So I went on a tangent there because it takes a little while for the Android emulator to spin up. It's quite slow. So we can see what it looks like here. Welcome to XamarinForms from XAML. Enter your name. David Burela. Say hello. Welcome, David Burela. Now let's bring this application up again on the Windows Phone. Debug, start a new instance. So we can see side by side what these two applications look like. The UI looks a little bit larger here just because I've set these to be different scales. So we can change this back to say David, and we can see that they look very, very, very similar. So let's spin it up on the iPhone. So we're going to right click, set a startup project. Going to change it to be iPhone 4S, and we're going to press run. Now when that happens, it's going to go, Visual Studio is going to take it, it's going to get all of our code, send it over to the Mac. On the Mac, you can see here in the top right, I've got something called the Xamarin iOS build host. That build host is waiting for Visual Studio to send messages to it. Now, you do need a Mac to do any iOS development. It's because Apple have a requirement in their build tools that you can only run the build tools on a Mac. So this is why I have these two machines sitting next to me. But it's fine because Xamarin have done all the niceness for us to connect the two. So the build host will build it. Once it's built it, Visual Studio would go and kick off the emulator and it will start running here. So we can see we have the application running here. It looks similar. So we have a label here, we have a text entry here. Change that back to David Burela. Say hello. Hello, David Burela. So the application looks like a native application. We can tell it to not go full width if we want, so it looks a little bit more normal, but that's user interface playing around with. Keep on typing more things in here. Hello, David Burela, ASD, this. Okay, so, and the good thing about it running here is if we stop debugging here, actually I didn't need to stop debugging, let's put a breakpoint here, so, and start it up again. So Xamarin have done all the coolness to get the two things connected to each other, so you can have the emulator running on the iOS, and when you do something, you hit a breakpoint, it's going to go back here to Visual Studio. So it's come back up, and then once it's finished loading, here we go. Enter your name, Burela. Click say hello, and then over on our Windows machine, it's inside of Visual Studio, it's hit a breakpoint. So we can see currently the name entry, it says Burela. Currently the greeting label is welcome to XamarinForms from XAML. So let's step over. We've created the greeting, hello Burela. So we're going to change the text from that, step over, it says hello Burela, hit continue, and it's happening here. So that's pretty cool. We're going in between two different machines here. Okay, so now that we've built up a very, very, very basic XamarinForms application, we've seen how to do things by being very explicit with the user interface, the interaction with the user interface. We inside of that click event, we're explicitly going, looking for each of those controls and explicitly doing things to those controls. Now, this is how many of us would get started when we're doing Windows Forms applications or hit a new platform for the first time. We usually do things just directly to controls. Now, there are better ways to do this. MVVM being one of these. So instead of explicitly interacting with the controls and interacting with the UI and having to know what the UI looks like, instead with MVVM, we're going to go and define the state of the view, and then the user interface is going to just react to the state of the view model. So going to connect, so we're just going to update the view model, and the UI will just update itself based on what's happening down on the bottom. So we're no longer interacting and manipulating the user interface directly. User interface reacts to what we've got in the state. So we have, I lied, that's not my last slide, I have one more slide. And this one last slide explains MVVM through an image. So at the front, we have a view. That view is going to be data bound to a view model. That view model is going to hold the state of our view. So it's going to have our customers and things like that. It's going to pull data down, and it's going to hold all the data for our view to display. And these view models are going to, its state is usually made up of a number of models which we are displaying on the view. So to give a concrete example, our view could be a customer orders view. Then underneath that, we're going to have a customer orders view model, view model. And that view model is going to be displaying customers and their orders inside of it. Now, these customers and orders could be retrieved from anywhere. So, inside of our view model, we're going to be holding what our current customer is. So we're having a property called current customer. And our view model would have another property, which would be a list of orders. And we could get these from anywhere. So for example, we could get them from a REST interface, an OData service. We could get them from old school WCF service if you want, etc. So today, what we're going to do is start off here and create a demo view. We're going to create a demo view model. And then we're going to have a property inside of our view model, which is going to have our greeting. Then we're going to add some widgets to it, so we can generate widgets inside of our view model. And then we'll have a list of models, which we're going to display on our screen. So we're going to go through this step by step by step by step, and at each step we're going to explain what's happening and why. So let's go back to our code. So demo view. It's okay to get started, but we're not going to be able to go much further than this. So let's close this one down, and we're going to create a new one. So inside of views, we're going to right click and add a brand new view. And we're going to call this the better view. Add it. Great. So let's just go back to the first view, select all of this, and let's just start off with that. Paste. Okay, so we've got a good place to start. Now, because with MVVM, our view is just going to react to what is happening inside of the view model. We are not interacting with the UI directly, so we do not need to have names on these controls because we're not going to be interacting with these controls directly. So same thing here, we are not going to have a clicked event because that would be directly defining what this is doing. So we've started with this. Now we've got the view side done, but we need to connect it to a view model. So let's create one of those. We're going to right click, add a new folder called view models. Now view models are just a plain standard class. So a good convention is whatever your view's name was, so better view, call it that better view model, 1L. Okay, let's clean this up. Public class better view. So we're going to need a few things. So this text up here. Well, first we need to connect the two things. So this better view doesn't know about its view model yet. So there are two different places that we could connect the view. Oh, there are multiple places we connect the view to the view model. the easiest ways for this demo is, so in the better view, we can do it inside the code behind. Clean all of this up. Now we could say when this view is constructed, we can say this binding context equals a new better view model. So we can do it this way. Another way that we can do it, if you don't like any code here, there we go, so there's nothing in our code behind now. We can go and do the exact same thing here, but in XAML. So content page dot binding context, and then we tell it to create, because in XAML, whenever you do things with these angle brackets, it will go and instantiate a new object of this class. So we can tell it to create a better view model. Now that's going to complain because it doesn't have the namespace for this. So ReSharper, if I click it, we'll automatically add it up here. So we've got the new namespace called ViewModels, which is this, inside of this portable class library assembly. And then we're creating one of them here. So we can do it here, or we can do it in code behind. It's just a personal preference. Now there are other ways that we could do this through dependency injection, etc., but we're not going to talk about that today. So we are connecting our view model to here. Okay, that's the first step. Now we actually need to have things in our view model for this to bind to. So let's put this down the bottom. So instead of our text being defined here, let's cut this. We're going to go to our better view model, and we're going to create a property to hold that text. So inside this view model, we have a string property called our greeting. If I can spell it correctly. So let's create a constructor. So CTOR to create a constructor, hit tab, and there we go. So we can say greeting equals welcome to XamarinForms from MVVM. Great. Let's hide that for the moment. So our view model, it's just a class which has one property on it called greeting. Great. We have our view, which is being bound to our better view model. So what we have to do is tell this label to data bind itself and retrieve its value from the view model. So we do this by typing in binding, and that was our property was called greeting. So if we set our Windows Phone emulator back to being the startup project, hit run, it's going to go off, and it's going to look exactly the same because we forgot to do one thing. If we go back to the app.cs, we are no longer starting off with demo view. We want it to be the better view. So let's start that again. There we go. Welcome to XamarinForms from XAML. So that's being data bound and it's all being brought through straight away. So it's, at the moment, it doesn't look like it's that cool. It doesn't look like it's that different, but you can see MVVM is very, very, very simple to get started with. You create a view model class, then you put in one line to tell it to connect to each other. Now, the cool thing about this is we can have multiple controls all binding to that same property, and then that's one property, everything is just bound to that one state. So we just have to change the state and our view will respond to it. So let's continue on. So we've defined it for this one. So let's do it for these ones. So the entry text field. So enter your name. Now, same thing here. Whenever we type text into here, we want it to just go and automatically update our view model. So inside of better view model, let's create a new property, which is a string, which is going to be the person's name. So back here, we're going to set the binding to be the name property. When we type things in this entry field, it's automatically going to go and update this name property inside of our view model. So let's just start off and initiate the name to be, please enter your name. enter name. Cool. We can start that up again just to make sure that that one is data bound as well. Cool, enter your name. So these two properties are now bound to these two properties in our view model. Now the last thing we need to do is bind our button to a method inside of our view model. Now with MVVM, you can data bind things to the view model. You don't just have to bind controls to just standard properties such as ints and strings and dates and colors. You don't just have to data bind to normal structs and classes. You can also data bind to methods via commands. So we can actually get our button to data bind to the view model. Now we do this through a command. We need to have an intermediary between the two. So we'll create one new property for our button to data bind to. So instead of being an integer or a string, we're going to create an I command, and this is going to be the say hello command. Easy. Let's go and change this button. You can still say hello, but we're going to say the command. Now every control, not every control, controls that you can interact with, they can have a default action which you can trigger via a command. So with a button, a default command would be when you click, for example. So with this command, we're going to, exactly the same syntax, bind it to the say hello command. Great, so our button is being data bound to our command property. So what we have to do is tell the say hello command, we have to instantiate it. We can create a new command, we tell it which method to call. So we're going to create a public void say hello method. This method is not going to do anything too difficult. It's just going to say our greeting property up here equals hello, and then our name property. Great, so let's put a breakpoint there. We're going to hit F5. Oh, no, because we forgot to do one thing. Our say hello command, we forgot to say, the say hello command is going to instantiate this. So our button is bound to this. We're instantiating that command, and that command is just really simple, and we'll invoke this method. Nice and simple. We're going to hit F5, enter your name, put in David, click say hello. Now through that data binding, it's come in here. That is not correct. Go back to app.xaml, better view, better view, better view model. What just happened there? Okay, let's just try rebuilding. Let's try cleaning. And then let's just run this again. That didn't work. Okay, let's manually do this again. We're going to right click, clean it all. We're going to right click, clean this, right click, rebuild. Check the output. Cool. Right click, clean, right click, build this again. Okay, for some reason be set to the iPhone simulator. So you can see here it was saying things weren't being built from MVVM. Okay, don't know what happened there. There we go. Okay, that's all good. Say hello. So the greeting is still that. We're going to step over. We can see it's picked up this from the property. So when we typed in that name inside of here, it automatically picked it up. Step over. Our greeting has been updated. Hello, David. We hit continue, and this hasn't been updated. Now, there's a very good reason why that hasn't been updated. Now, when we are using data binding, all of the controls are smart enough to, when we first start up the view, it knows to connect the controls to those properties. So via data binding, it will all do one-time data binding, and when it's first instantiated, it will connect to that property, get the current value, and update itself. So at the beginning, the labels, the label up the top, the greeting label, went and got the greeting, put it up there once. Now, our view doesn't know when to update itself again. It doesn't know when the view model has been updated. So we just have to give the view a little hint to let it know whenever the view model changes, so that it knows to update itself. Now, we can do that very, very, very simply. So our better view model is going to implement iNotify property change. Now, with if you just have plain Visual Studio, or with ReSharper, Alt-Enter, you can tell us to implement. But with Visual Studio, Control period will bring this up. So we can implement the interface explicitly. And here it is down the bottom. So iNotify property changed. We're going to create one helper method, public void on property changed. So when we data bind and the views see that our view model implements this interface, then all of the controls will subscribe to this event, property changed. So what we need to do is when our view model changes, we need to go and trigger this event, so then all of the controls will know to go and refresh themselves maybe. So we can call our onPropertyChanged. We can tell it the name of the property that changed, property name. So we're going to say, hey, if property changed doesn't equal null, so making sure that we do have some controls that are subscribed to it. If they are, we're going to trigger that property changed event. We're going to say that the view model was the sender, and then we're going to say the name of the property that changed, which is property name. So that's it. We just have to write 2 lines of code to implement this. Now in Visual Studio 2015, you'll actually be able to just go remove all of this. You'll be able to go property change dot, question mark dot. So then if this isn't null, we can go and begin invoke, etc. But as we can see, this is a C#6 language feature, so I can't demonstrate this today. But when this comes out, this will save us 1 line of code. Great, so all of this, we write it once, and then we just hide it away. So we're going to surround that with a region and just call this iNotify property changed. We're going to hide it and never mention this again. Great. So we're updating the greeting property, and we need to, when we do update this, we need to just tell the view, hey, we're updated. So we're going to change this from an auto property. Now, instead of doing it manually, I'm going to use the power of ReSharper to just change it to a property with a backing field. Nice and simple. So we can say, whenever we go and set the value, then call onPropertyChanged and say that this property has changed. So whenever we go and set a new property for greeting, we're going to trigger an event to say, hey, this property has changed. Any property that is data bound to a property called, any control that's data bound to a property called greeting, you may want to update yourself now. So that's all that's happening here. So if we hit F5, run this again, and to name, we'll put in Bob. Say hello to Bob. Step over, greeting is hello Bob. We hit run, and now it says hello Bob. So we've now done what a lot of MVVM frameworks implements. You don't need to use an MVVM framework. You can just hand write it all by yourself here. MVVM frameworks can give you some extra niceties, but when you're getting started, look, just do it by hand. I've shown you, you can do it with just a couple of lines from scratch. Okay, so we've done the basics. Well, let's just see this running on Android as well. Just so we can say just so we can check this is all working on multiple platforms. Now, this time, you guys, I'll let you sit here and watch just how slow the Android emulator is. Yep, getting installation path, etc. As I said, as soon as 2015 comes out, make sure that you get it. There has been some rumors that, well, Visual Studio is going to be releasing a community edition with 2015. The community edition is going to be as powerful as Visual Studio Professional, but it's free for anyone doing open source work, or there's a few other licensing restrictions around it. So there'll be Visual Studio 2015 Community Edition, which you can use for free, and rumoredly there's going to be a Xamarin edition that will work for free inside of the Community Edition. I'm not sure if that's correct. But either way, make sure you upgrade to Visual Studio 2015 so you can get the much faster Android emulator, because you saw how much I tried to talk while this is all happening. So the Android emulator finally came back. We've hit our same breakpoint, so we can debug in every single environment. There you go. Great. So we've seen that we can, with a couple lines of code, create a view model, data bind to that view model, implement iNotify property change, implement commands, and we can get them all working with just a couple lines of code. So we're going to repeat this again, but this time, instead of doing it with greetings, we're going to create widgets. So we're going to create, add 2 more controls to our view. We're going to have a label, which is displaying how many widgets we have created. And then we're going to create a button, which just says create widget. So whenever we click that button, we're going to invoke the widget creation system in the backend. The backend is going to take 2 seconds to create a widget, and then it will tell us that a widget has been created, and we're going to update the number. Very simple. But I just want to do it a second time, because now that you've seen me do it once, you can see all the pieces being done again a second time. So let's go back to the view. So under all of this, let's add a new button. Text is going to be create a widget. Then we're going to have a label. The text is going to be a binding to the widget count. So the button, we know we're going to need it to be bound to a command. So let's bind it to the create widget command. So we're going to need to create these 2 properties on our view model. Let's go back to the view model. Let's create the widget count. So prop int widget count. Now, because we're going to be updating the widget count, we're going to have to tell the UI when it updates. So here on property changed, we're going to say widget count. Great. So our property is done. We can collapse it if we like, so everything looks neater. There we go. Property for widget count, we're going to need to add a new property, a new command, our create widget command. We're going to have to tell that create widget command is a new command, but we haven't created the method yet, but it'll be a create widget command. Whoops. It's going to be a method called create widget. Now we can actually tell it, you know what, just generate that method for us. Use all the shortcuts when you can. So create widget is going to be nothing more than, so we're going to create a widget by calling the backend widget web service. So we could go and implement all of that, which would, we could go and invoke a HTTP client to go and trigger backend logic, etc. We're going to pretend that we've done all of that, and we're going to go task.delay 2 seconds. Now this is complaining because we're telling it to await, so we need to say this is an async method. Easy. So we're going to pretend we're creating a widget by just pausing for 2 seconds. Then we're going to say widget count plus equals 1. Cool. We hit run. It's going to take ages because I told it to do it in the Android emulator again. But let's just let that spin up. So take a few seconds. There we go. Dev Superpowers, and finally, again, Visual Studio 2015 emulator will be much, much better than this. There is the, as I mentioned before, the Intel Xamarin emulator, which is much faster, but it conflicts with hypervisor, so you can't do it. So if we click Create Widget, it's going to go 1, 2 seconds, a widget's created. Click 1, 2, a widget is created. Now, fortunately, we have no feedback. We don't know if a widget is being created or not. So we might click and go, hey, wait, click it. Oh, wait, there's no widget. But then we've queued up multiple widgets to happen. So what would be good is if we had, before I forget, we'll set our Windows Phone project. What would be good is if our user interface told us that we're doing something. So let's go and create an activity indicator. So this activity indicator would show us that we're waiting for something. Now we can say, if we scroll up, there we go, is running. So is running, we can set it to be false when it's not running. We set it to be true when it is running. It'll show us a progress indicator. But it's the same thing. We can actually tell it to bind to something. So we can bind it to our ViewModel to a property called isBusy. So we could create a Boolean inside of our ViewModel, which we can set to be true or false, which will trigger this to be true or false. So let's go back to our ViewModel. Let's go back up. Create one more property. We'll make this a bool. We'll call it isBusy. You know the drill. We're going to create it with a backing field. We're going to say on property changed is busy. Okay, so we have a property. Now we just have to set it to be true and false when we're doing things. So when we start, we're going to create a widget. So we're going to have to say is busy equals true. We're going to go create the widget, increase the widget count. Last thing we do is say is busy equals false. If we hit run, spin it back up. So create widget, you can see the progress indicator, widget, progress indicator, new widget. Now the next problem we have though is we can see that it's busy, but we can actually click it multiple times. And so if we wait, we'll see this number will go up again and again later. So what we actually want is when this is busy, we want to disable this button so that we can't click it again. And you can do that. Now via this button, the create widget, we've got the command. There is actually another property on here called is enabled. So same thing, we can set it to be true or false. Now, we can do a binding again, but setting it to be is busy won't work because when it's not busy, it'll be false, which means that it's not enabled, which means we can't click it. And so what we actually need is to be a flipped Boolean. Now, we could use a converter, so we could use a Boolean not converter to do it, but I don't want to get into converters today. So we're going to just do a hack. So we've got an isBusy property, so why don't we just add another property called bool, which is called not isBusy for the reverse of it. We're never going to set this, and we're just going to define the get, which is going to be not is busy. Whoops, we need to return not is busy. So just the opposite of this. So that's all well and good. So we can say not is busy. That's great. So we're data bound to it, but we're back to the same problem we had of we won't know when not is busy is updated. So whenever we update busy is busy, we can tell it to update any properties which are dependent on this one. So we can say, hey, whenever we update this value, tell the user interface that any controls that are bound to the is busy property or the not is busy property to update themselves. So if we click run now, if we click create widget, see it's now disabled and I can't click it again. When it's finished, it comes back. So this is what I was talking about right at the very, very beginning. How one of the advantages of MVVM is that we no longer do any interaction with the view directly. The view is just very, very simple. It has no logic. It's just a dumb shell. It does nothing. All of our logic sits inside of the view model because the view model holds the view state. So all we have to do is just update that view state and the user interface just reacts to what's happening. So we can see here that the user interface is reacting to it being busy, reacting to widget counts being updated, reacting to us entering in people's names. Now this is great because it means that we can actually test pretty much 100% of our business logic for this view now, because we don't have to test any UI updating code. All we have to do is just test all of our view model code and make sure that all of that logic is sound. And our view should just react to that good logic. So we've now created a view, we've created a view model, we've created a bunch of controls, etc. So let's create one more view, one more thing. If we go back to my slide, we can see that we had a view model and some models, but we're not actually displaying any models here. So what we're going to do is create an animal class. Our animal class will be our model, and our view model is going to hold a list of animals. And then in our view, we're going to have a list view control which can display a list of our models, which are animals. So let's just show the last piece of this puzzle. Right click, we're going to add one last folder called models. We're going to add a new class, we'll call it animal, make it a public class. Whoops. Okay, so our animal, so models are extremely simple. Let's have a string, which will be the name of this animal. Let's have an integer, which is the age of this animal, and let's have another string, which will be the color, Americanized spelling, but the color of the animal. And that's all we need. Models are very, very simple as well. Okay, so let's go back to our view model. Collapse this. Oh, so before I move on, so I'm sure some of you are screaming in the comments and commenting in the live stream already that this is one way to do it. Now there are multiple other ways to do it. So some MVVM frameworks will give you other ways that you can do this. Another way that you can sometimes do this is within the command. So within the command, if we go comma, there is actually a func here where you can go and define logic to define whether we can invoke this command or not. So we could say that we can only invoke this command when it's not is busy. I'll put in a bunch of stuff like that. So we can say whenever we are not busy, then we can invoke this command. Now, unfortunately, Xamarin.Forms at the moment will not change the state of the button to be the enabled and is enabled will not automatically happen. The button will always be enabled, but when you click it, it will not invoke the command if this doesn't work. So because it doesn't update the UI, I didn't do it that way today. Instead, we did it with our nice little hack. But again, you probably use a binding converter rather than defining the opposite boolean. Okay, so moving on, we have our animal. So let's create a list of, let's create a property, which is a list of animals, and import the namespace animals. Now, one problem we have here now is we have a list. Now we're going to have the same problem here that we had with our properties. If we add or remove items from this list, the user interface won't know to update itself. Now they've done all the work for us inside of the .NET framework. There's actually another list called an observable collection. And whenever you add or remove items from this collection, it will automatically send list collection changed events. So then any controls that are bound to it know to update it themselves. Okay, so that one was much simpler. So same thing here. Let's instantiate our ViewModel property. Animals equals a new observable collection of animals. We're going to just inline add some. So we're going to create a new animal. Let's see, we'll go name equals, so let's have a animal called Fluffy. Fluffy is only 2 years old and Fluffy is white. Let's add a second one, animal name equals Spot. Spot is a little bit older, 4 years old. Color, let's go black and white. Last one, new animal name equals, let's go Rex. Rex is an old bloke. And what color is Rex? Let's make him a red color, red Rex. Okay, so we've got our list of our models. Now inside of our view, we just have to have a way of displaying this. Now we can do this with a list view. Our list view, instead of binding the text, it's got one called the items source. So where does its source of items come from? It comes from a binding from our view model and bind to a property called animals. Great, so we can actually just start here, press run, and we've bound to our collection of animals. So these could be our customer orders, they could be a list of customers, etc. Now, it's done the best that it can. It knows that it's a list view, and the list view is bound to a collection, and our collection has 3 items in it. But it doesn't know how to display the item that we have there. It just knows that it's an object. So the best thing that it can do is just do object.toString, which you go and print out the full name of the class, which is Dev Superpowers demo.models.animal. So we've got 3 of those. So what we need to do, stop here. What we need to do is define how each of these items should be displayed. So if we go list view dot, just to be item template. We can define the template for each one of those items that it is displaying. So if we're saying how it's going to be doing it, we need to define a new data template. That data template is going to have a view cell to hold everything. Inside of that, let's have a stack layout. Inside of that stack layout, we're going to have 3 labels. So we're going to have one label, text, binding to the name, one binding to the age, one binding to the color. So we could go and say, hey, around each of these stack layouts, we could I've forgotten the name, so let's pretend that we could define, if there's a box around each of these, so we could define a border. I've forgotten the name. So let's just hit F5. And there we go. We have 1, 2, 3 different items here. Fluffy to white, Spot. And if we wanted to, we could change this to the stack layout. The orientation is horizontal if we want. it'll probably look all horrible and mushed together, but I just want to show you, here we go, fluffy to white, spot floor for black and white, rec 6 red. Okay, so our UI is looking a little mangled at the moment, but it's going okay. So I'm not showing you how to design beautiful user interfaces using Xamarin.Forms, I'm showing you how to use Xamarin.Forms. So one last thing I want to show is we've got views and view models, and we can actually just use them all. So let's create one more view. Now, if you remember the picture I showed you right at the beginning, we saw that we were using a tabbed layout. So we're going to do the same thing here. So we're going to create a new main view inside of here. Our main view, let's just clean up all of this code that's in here. Doesn't need anything. Okay. Now our main view, instead of being a content page, it was a tabbed page. Now our tab page is going to have 2 children, and those 2 children are going to be those these 2 things. So let's have one which is going to be one called the demo view, and with the power of resharper we can tell it to bring in that namespace. We can tell it to also go views. So here we go. Once we're bringing in the namespace we can see them all. So let's bring in a second tab called better view. Okay, we're going to hit save. Now our tab view is going to display these 2 views, but it doesn't know the name of these views. So what we can do, inside of better view, we can say that the title is better, and inside of demo view, let's add a new title, another a title, and let's just call this original. Hit save. Now let's go to our app.cs, so instead of better view, let's make this start up the main view. Now, if everything has gone correct, let's cross our fingers. It didn't crash, yay! So we can see, if we go back to demo view, no, we want a main view. So our main view, we're saying we've got a tabbed page, so we've got the 2 pivots up here, and the contents for each of these, if we go across, we're telling it to just go and instantiate a new demo view and a new better view. So this will go and instantiate a new demo view. This one will instantiate a new better view. And when better view instantiates itself, it creates a new better view model. That will data bind to itself, which will go and data bind the controls, which will connect all the iNotify property change events, which will do everything awesomely for us. So we can see that all of this application is not many lines of code, but everything is just reacting very nicely to what we're doing. So all of this stuff still works. If we go back to our original one, all of this, get rid of our breakpoint, all of this is still working. So both of these views are still working independently. To flick around, the updates to 3. All of that is working nicely. So we can actually stop this. We can go and see what it looks like on all of the other platforms now. So set our Android application. Once that one has finished loading up, we're going to go and do the same thing with the iPhone, and it should all look fairly similar with all of the controls. Now, again, it may not look like the prettiest user interface because I'm just using a stack layout here, and for my list view I was just very, very quickly defining an item template for them. So if we spend a bit more time on here, we could make this look sexier, but I'm not here about the sexiness, I'm here about the code. And common Android emulator. You can see the CPU going and here we go. Let's bring the WinForms one up at the same time. let's compare them to each other. There we go. So we've got the pivots up here. We've got the two different tabs across the top, which is really, really slow on the Android emulator. And so everything should still work the same. If we click Create Widget, we've got an activity indicator here. We can see that we have our list here. We can click all of this, our list. We can still say hello, and we can say hello here. Everything is working great. So let's take a screenshot of this, so then we can compare it side by side with the iPhone in a moment. So set the iPhone, we're going to hit F5, it's going to go, package all of that up, send it over to the source code over to here, the build host is going to build it, and drum roll, intermission music. Here we go, launching application for debugging. So things are usually faster. It may be because I'm recording and streamcasting and I'm going over a Wi-Fi network today that everything's being a little delayed with the iPhone, but usually it's quite fast. So if we look at here, now if we compare side by side the screenshot of this with a screenshot of what it would look like on Windows Phone and Android, then we can see that they look kind of similar, but this time we've got the tabs down the bottom. We've got original and better coming here. So this should still work as we'd expect. Hello, flick across to better. Now, we didn't consider that the iPhone has things up here. So if we were, again, making our user interface sexier, we would go and make sure that we're not banging things right up against the top. But we can see that our list is here and looks like a native iPhone list. We've got Create Widget, we click, we've got the native iOS activity indicator. We can enter our name up here. We might not be able to see it, but say hello. So all of our commanding, all of our data binding, all of our everything is all working, and it's working cross-platform. So with that, we have tab layout. So one last thing, very, very last thing I want to talk about is I mentioned that we could have done the commanding a little bit differently. Now we could have made a few other things different. Now iNotify property changed. Instead of manually passing in the string name automatically, as a magic string, which can be wrong. Go up here. So we could go and upgrade this. So instead of taking strings, taking a function. So we could pass in a function which is the property that we want, a func that takes in a property. So then if we ever refactored and changed the property, it would automatically change the name that's being passed in. So we could do that. Another update that we could do, an improvement, is at the moment, whenever we update this, we're always going to go and send out trigger property change events. But if the value didn't change, maybe we're doing some extra work that we don't need. So we can say if is busy doesn't equal value, then only at that point go and do all of this stuff. So we could add that enhancement in as well. So a bunch of few little optimizations that we could put in here. But for simplicity's sake and getting you kick-started, we're going to leave it at that today. So with that, I hope that all of you got a deeper understanding of Xamarin.Forms and that it is quite simple to just define it once inside of XAML, and it's going to look the same. In this case, it's going to look the same and terrible on all the platforms because we didn't spend any time on the sexiness of it. But you also saw that you can write your code once in C# inside of XAML, and our user interface is going to be very reactive to what happens inside of that. And that will help us simplify all of our coding. Now, I have tried on a couple of projects. I think to myself, I'm doing a little quick application. I don't need to implement MVVM. I'm just going to go and update the controls manually. And so I've done this multiple times in little projects, but they always expand and I go, oh, things are just so difficult now. I wish I have done MVVM from the beginning. And so now you've seen it's so simple to get started with it. It's 6 lines of code. So now just do it by default. So I hope all of you got a lot out of that. Now remember, if you did enjoy this video, we do have a whole video series on DevSuperpowers.com. So go onto there and see more videos which are similar to this. If you do have any questions, feel free to contact us either by leaving comments on the video or contacting us at SSW_TV. And if you want more content like this, please subscribe to the SSW TV channel on YouTube. And remember, like and favorite and leave comments if you like this video, because all that sort of encouragement makes me want to create more of these videos for you. So I'm David Burela. Thanks for joining us.